Okay, so good day to all of you. So today we're going to apply Matlab on some concepts of Module 1. So I have here class the PowerPoint lecture and then I have here the software of Matlab, okay? So as I've mentioned class, so this is the objective of today's lesson to apply Matlab on some concepts of Module 1. Okay, so let's start with the first topic, which is about limit of a sequence. Okay, so in MATLAB class, limit is defined to be the limit of symbolic expression. And we have the following syntax here. So we have limit of f var a. Okay, so this is the syntax that returns the bidirectional limit of the symbolic expression f when variable approaches a. Okay, then the second one, limit of f comma a. So it uses the default variable found by SymVar. Then the third syntax limit of f. Okay, then the fourth syntax is limit of f of var a left. Then the fifth is limit of f var a right, separated by commas. And then take note also that we have a single quote for left and right, no? So use the syntax class because if you will not follow, then you will have a syntax error. Okay, the last two syntax here can be used to evaluate limit of a function where we have one-sided limit, which are left hand limit and right hand limit. Okay, so we cannot use this to use in our Mat 148 class, no? So we can use class the first and second. I We will check later class also if we can use the third one. No, I have not used that yet. Okay, so let's now have the example. Okay, so we have this example class that we have dealt with in our lesson. So this is solve for the limit of the sequence n plus 1 as n approaches, of course, infinity. So we use the indicated limit class n approaches infinity, okay? So if we are to evaluate this limit of sequence n plus 1 as n approaches infinity, the result is what class? Manually, what's the answer? It is, what's the answer class? Limit of n plus 1 as n approaches infinity. Okay, the answer is infinity class now. And with that, let us check using Matlab, okay? So what you will do first is to declare the variable present in your sequence, which is n. So class, take note that in declaring variable, you use the command or function sims. Okay, so sims. Then your variable present in your sequence. So this one is n. Okay, so if you see here another variable, let's say k, or a different variable, let's say k, so you type k here. Let's say you have a variable x, so you type here x. Sims x, sims k. Okay, so you have to declare that class. Why? Because if you will not declare it, Matlab will not push through with its computation. It will give you a syntax error. Okay, then next is you declare your function, okay, which is n plus 1. So we use a name for that. So you can use f, or you can use any other letter. Okay, so we have n plus 1. Then if you will not use the semicolon here, Matlab will display the output. You see here class m equals 1 plus n. Okay, And then let us try class if we will use semicolon. So it will not display the output. But don't worry class, it will not affect no the MATLAB computation if we will or if we will use semicolon or not. Okay, then you declare class your indicated limit, and that is infinity. That is your A. Okay, so that is A equals infinity. So for the infinity symbol class, so we use in the Greek letter infinity, right? But then in MATLAB, we use the expression INF or the word INF. So you can also use capital I if you want to use capital I. Okay? So with that, if you don't want to declare, it's okay class. If you want to declare it, I mean, if you want to have MATLAB out display the output, so do not use semicolon. Okay? If you don't want to display class, so use semicolon. Okay, the next item, we now type limit class. Okay, limit, because we're going to find out the limit, no? Limit of f, that stands for your function n plus 1 here. Then your a. A stands for infinity class. Okay, let's use the first syntax class. So let's have the variable n. So this is the answer. As we also found it manually class, the answer is infinity. Right class? If I will use limit, the second syntax, do we have the same answer? Yes. Okay class? If we will just compute, we will just use f class. So let us check. The answer is 1. So it's different class. Why? Because it says here it returns the limit at A. It returns the limit at A. So we are in doubt with that class. So don't use this class now. Okay, class. Please, because manually our answer should be or our answer is infinity. So therefore in MATLAB it should also be infinity. Okay, next item. Suppose we are solved for the limit of the sequence 1 over 2 raised to n. Okay, so class, as you can see, we have typed many commands here, class, right? So you can clear this by typing CLC. Clear screen stands for clear screen, okay? Or clear command, okay? CLC, clear command. Okay, so with that, let's now have this class. So let's type first since n. By the way, class, when we manually compute this, what's the answer? So 1 over 2 raised to infinity. 2 raised to infinity is infinity. 1 over infinity is 0. So the answer is 0, class, no? So we expect that MATLAB will have an answer 0. Okay, so next, type your function f equals 1 over 2. Okay, the exponent is n, right? So we use caret class. Okay, so this symbol stands for caret. It is the tab 6, but you have to use shift. Okay. Now, if you want to check class, if you have the same expression as we normally write 1 over 2 raised to n, so we can use pretty f. So that's a special command class. So it denotes class writing the function into the normal, okay, way you write a function. Okay, so let us check. See, that's 1 over 2 raised to n. Okay, next, you have to declare also the indicated limit, which is a equals I and f. Okay, so I can use semicolon if I don't want to display the output. So it will not affect class the computation of Matlab to the expression that you want to need to evaluate. Okay, so with that, let's now have limit. So class, I will not type any more limit. So what I will do is to use the up arrow key. Okay, so you see these different commands that you have typed previously. Then use the one here, class limit of f and a. Okay, so the answer is 0. So it computes class what you have just typed. Now, the other commands or expressions that you have typed were overwritten. Okay, so let us check class the other limit of f a. So the answer is also 0. Okay, class. Are there any questions so far?
None po.
Okay, so next let's have another sequence or series and let us evaluate its limit. Ah, no more. Okay, there are only 2 problems provided. Okay, so if you want, we can check other expressions. Okay. Okay, let's have another example. So CLC. Let's think of a function. Let's say since variable x and the function that we're going to evaluate is f equals, you have 3x cubed. So that means 3 asterisk x cubed. So we use caret plus. Okay, then plus, sorry, I just write here 8 x cubed plus 27. Then all over, let's say you have 9x cubed tiny weight class. Okay, let's continue class. So suppose this is 9 times, okay, so 9 asterisk. Let's have the same exponent class. Then minus 27. Okay, so we can type again plus PT F. Okay, so you don't want to type PTF, just recall what you have typed a while ago by using your arrow key, then press enter. Okay, so that is plus your given function. So then you have your indicated limit a equals infinity. Then take now the limit class. So I'm using my arrow, up arrow to class now. Ah, sorry. Sorry for that class. I forgot to change the variable. Now it should be x. Okay. So the answer is 8 over 9, right class? You remember last time when the degree of the numerator is equal to the degree of the denominator, so we just get the leading coefficients of those degrees, right class? Then eliminating the other terms, right class? So the answer is 8 over 3 here class, no? Or rather 8 over 9, sorry for that, 8 over 9. So can we use the other syntax class, limit of f, comma a? Yes, it's still 8 over 9. Okay, class. So are there any questions? So for class, do you have any questions?
None po, sir.
So far, none po.
Okay. So we go now to another syntax class. So this is about getting the sum of series. So we use the syntax sum class, okay? So according to Matlab, sum is sum of series, and these are the syntax class. But we will use only the first syntax, and that is sum of f, comma k. So k is your variable, then a, b, where a class is your lower limit and b is your upper limit. B is always infinity class. Now remember in the sigma notation, okay, so the lower limit can take any value plus starting with 0, or you can use 1 as your starting n. No? But then the upper limit is always infinity. So B is always infinity class. Okay, so this is the description class for this sum f, comma k, comma a, comma b. So it returns the sum of the series f with respect to the summation index k from the lower bound a to the upper bound b. If you do not specify k, sum uses the variable determined by var as the summation index. If f is a constant, then the default variable is x. Okay, so let us take these examples, class, or let us have an example. Okay, so what happened with us? So I'll just check. Okay, so sorry for the technical error, class. So we're gonna do the examples of sums of series where we will use sum as the syntax class or command. Okay, so this is the first example. So we're going to find the sum of this series 2n over n plus 3 from n equals 1 to infinity. Okay, so class, if we're going to compute this manually, what's the sum? Or I should say, what test are we going to use to get the sum of this series? Do you have an idea what test? We have already learned the different tests class of convergence. Also, the
Root.
special types root test. So we cannot use root test here because there is no n power exponent or n exponent here or exponent n here.
Sir, ratio test po.
Okay, so ratio test. Okay. Yes, we can use ratio test. Uh, but let us use the one that is more appropriate. What do you think, class?
Term test.
Hmm? What is it, anak?
Term test po.
Root test? Ano ba yan? Sabi mo? You cannot use root test, anak, because there is no power n.
Okay.
Yes, anak. Okay, what other test, anak? Can we use integral test here? No, because this is not integrable. And the function, I think, is not decreasing values. Decreasing values ba siya? Because from the look of it, anak, hindi siya integrable, no? Okay, so integrable man siya, but we will use substitution method, and maybe it will make things complicated class. Ha? So yung pinakamadali, what do you think? Divergence test, anak. Okay? So, di ba class, divergence test. So, take note that the commonly used test is divergence test before you use the other test, ha? Okay? But sometimes, class, ang problem lang kay divergence test is when it is evaluated to be inconclusive, right? So, use another test. Okay? So, with that, let us now manually compute class. So, we apply limit class, right? So, what's the limit of 2n over n plus 3? So, we can use Matlab if you want. No? Limit siya, di ba? So, what value will it give you plus 2n over n plus 3? So, they are of the same degree, right? The answer is equal to 2. You just get the leading coefficient of the leading exponent. Both are equal to 1. So, 2 over 1, right? Is equal to 2. So, that's the limit class. And it is not equal to 0. So, the series diverges, right, class? Okay, with that, we can easily now identify the sum. The sum is what, class? A divergent series has no sum. So that is the answer. Right, class? That is manual computation. But in Matlab class, so what you will do is to use the same sum. Okay, so let's clear this command window again using CLC. Okay, then you now have to declare the variable which is seems rather. Okay, then the function here class f equals, we have it as 2 asterisk n all over. So use right slash, then n plus 3. So let us check class if you use this n plus 3 now without parentheses. Or you see, you'll have a different output. It is not the way no, that we see from the given, right? Class maybe n here cancels, then 2 plus 3 is 5, right? That's the answer provided by Matlab. So that's why class, this is a sensitive class. So we use parenthesis class to separate terms class now and make your expressions typed in the command window of Matlab same as in the given problem. Okay, so let us check this now class. You see that? Then we can use pretty. Uh, so I don't have yet pretty now. So this command pretty will make your expression same as what you have in the problem, no? Pretty f. Okay, because that's your function. So open parenthesis and close parenthesis f. So you see, class. So I have now the same expression, no, as provided in the problem. Okay, 2n over 3 plus 6. So with that, we can now have sim sum. So sim sum of the function. So this is the syntax class f. Okay, then comma, then your variable is n, comma, then the lower limit is 1, then the upper limit is in. So the answer is infinity. This is the answer provided by Matlab, but we know that INF means the series has no sum, right, class? Okay, so you just conclude that way, class. Huh? Are there any questions? By the way, you can directly input the series or expression on your syntax here, class. So as you can see, sim sum, then you have your expression. Okay, so if you notice, class, the one that has parentheses is 2 asterisks n, no? But for n plus 3, there's no more asterisks, except, of course, the outer part, no? Which is enclosed by parentheses. So in here, I separated the second expression n plus 3 by parentheses to your numerator, which is 2n. Okay? Are there any questions for this class? First example.
None.
Okay. So we go now to the second problem here, class. So we have here summation of 5 over 8 raised to n from n equals 0 to infinity. Okay, so manually, class, how do we compute this? So using what test? So this is a geometric series, class, right? Okay, remember, class, the general form of geometric series, it is a times r raised to k. A here is 5, then your r here is 1 over 8, and your k here is n. You follow? So with that, we know already, class, your r, right? So we know already your a. So we know that this is geometric series, right? Because we have ratio 1 over 8. Then it is less than 1. We take the absolute value of r, which is 1 over 8, less than 1, the series converges. And a convergent series has a sum. And the formula for sum of geometric series is a over 1 minus r. So as you can see, you have 5 as your a, then 1 minus r is 1/8. The answer is 40 over 7. So that's how we manually get the sum of this geometric series, right? Okay, using now sim sum command in Matlab. Okay, so let us do this, class. Again, CLC. Okay, so what's your variable? Again, is n. So you declare that sims n. Then your function here, class, is 5 all over 8 raised to n. Okay, let us check if it resembles with the given problem class. So we use PTL. So same class, no? So with that, we can now get the okay sum, no? Using sim sum. But then, class, take note that you have your n equals 0 here, you have n equals 1. So you remove that and change it to 0, class. So the answer is 40 over 7. If you will not change that, class, it will give you a different answer, which is 5 over 7. Okay, class? Questions for this second example?
None po.
Okay. Let's have the third example here, class. Find the sum of the series 1 over k from k equals 0 to infinity. Okay, manually, class, the answer here is what? No sum, because the series is a harmonic series, and a harmonic series always diverges. Right, class? So there's no sum. Okay, so checking now the answer in Matlab for this series. So we type again since, so this time it is K, class. Then we now have to type your function f equals 1 over k. Okay, next, if you want to have check this class with the original expression, you use 3tf. Okay, that's 1 over 2. Then plus, you now take the same sum. So take note of your lower limit, which is 0 plus from the given, no? Okay, problem or series. So the answer is, sorry class. I forgot to replace n by k. Okay, so this should be k. So the answer is infinity. Okay class, so don't forget that to replace your n by k, just like what I did here. So the answer is infinity, so that means the sum of this series has no sum. I mean the sum is none, no? Okay, no sum. Let's have another example. Okay, so we have find the sum of the series summation of 4 raised to k. Okay, so what about this class? There's no lower limit, but the upper limit we can use the infinity, right class? Okay, so if you can class use k equals 0, yeah, you can use 4 raised to 0 is 1, right? So it's okay. You follow? So you can use 0 as your starting value for your n. Okay? There is no lower limit, okay, found in the given series. But if that k value equals 0 is not applicable, use k equals 1, plus. Okay, so you have to check also if that lower limit can be used. Sometimes it is not given, okay? So in this case now, if it is equal to 0, that's your lower limit, but we are going to compute it manually. So 4 raised to infinity, right class? The answer is infinity. So, and by the way class, this is also geometric series, right? Okay, so what's the R? R equals 4. 4 is greater than 1, so the series diverges. So a divergence series has no sum. Okay? You can also use divergence test. So 4 is infinity not equal to 0, so the series diverges. Okay? So with that, let's now use Matlab class to verify if the answer is correct. So again, class, you have this CLC, then seams K. Then you have your function f equals 4 raised to k. So you use caret class for caret k. Then you now have to take the sum. So take note of the lower limit is 0, and then variable also is k. So the answer is infinity. Okay, class. So with that, this series has no sum. Okay, next item, we go to this given series. So 1 over n squared plus 7n plus 12. So what appropriate test can be used here, class, to find the sum of this series? What appropriate test, anak? It is the telescoping sums, anak. Now remember last time, if you have a polynomial in the numerator, which is factorable, so we can use we can use telescoping sums, anak. Okay? Even if you have a polynomial in the numerator, this one we have a constant, right? But then The denominator is a polynomial that has factors or can be factored or it is factorable. So with that, you will need to define the closed form of this series by using partial fractions. So this is the obtained closed form class. And from here, we can now generate some terms in your series starting with n equals 0. So what will be your first pair? 1 over 3 minus 1 over 4, right? Plus your second pair values plus when n equals 1, 1 over 4 minus 1 fifth. Okay? When n equals 2, 1 over 5 minus 1 over 6. And so on and so forth. Then you can write this expression again. Okay? Because that's your general term class. I just did not include it because of the time or rather space constraint. Okay? So you need to include that. Then class, take a look now at your generated terms. There are terms here that can be cancelled. So you have now negative 1 fourth plus 1 fourth is 0. Negative 1 fifth plus 1 fifth is 0. Then negative 1 6 will cancel with this 1 over n plus 3 or 1 over x plus 3. Sorry, there's a typo here. This should be n plus 4 because the variable here is n. No? Again, class, negative 1 6 will cancels with 1 over n plus 3. Why? Because it's the second term cancels with the first term. So second term here cancels with the first term. So this is what is left as well as 1/3, right? So we take now the limit of 1/3 minus the limit of 1 over n plus 4. This will be 0. So what is left is 1/3. So that is your manual formula or rather manual solution. Now for Matlab, we can easily get the value of the sum of the series, which is 1/3, by using sim sum. Okay? So you have this now class. Again, the variable present here is n. So you need to declare that since n. Then after that, you now have to define the function f equals 1 all over n asterisk 2 plus 7 asterisk n plus 12. Let us check the output class. It should be the same as what is written in the problem. So there's a missing parenthesis here class. Sorry for that. So what if we are not going to use parentheses? So let us check. So it will give us a different expression class, right? From the given. So what we will do is to use parentheses class. So take note of that. Okay. So on both ends of your denominator, you use parentheses class. So let us take pretty class to check further. Okay, so it's the same now class. It's just that here constant is written first, no? Plus 7 and plus n squared. It does not matter. Okay? So we are now to find the sim sum. So it starts with n equals 0, but then class you need to replace k by n. Okay? So the answer is 1. Okay, class? Questions?
Yun po.
Okay. So class, if you're planning to use Matlab, of course, you need to provide also the manual solution. This Matlab solution will just verify if your answer is correct. It's your option to use Matlab class during the quiz or exam. No? I know that this will be a burden class. If you're going to use this Matlab, no, it will add time, no, in doing your solution. But then class, if you want to verify your answer if it is correct, you can use. It's your option to use it or not. Okay, class? So just like what we have here, class, no, I provided here a solution, then the MATLAB solution. This is what I will expect in your exam. Okay. Very, very important note that class, you should have manual solutions. If you don't want to have a MATLAB solution, it's okay. It's your option. Now, if you have used MATLAB solution, you need to provide me also class, huh? And of course, it should bear your name here, huh? So take screenshot of the of this part, including your name, okay, class, so that I can be able to, or I will know that you are the one who of course, I may know if you really use MATLAB class, no? Okay, next item, let's have Taylor series. Okay, so the syntax here class is Taylor, no? What about Maclaurin? Okay, Maclaurin series is a special case of Taylor series. So in MATLAB, we only have this class as the command, no? Okay, so it also computes the Maclaurin series. Okay, so this is the syntax class, or these are the syntax. F equals Taylor, F, comma, var. Okay, then the second one, by the way, for the first one, it approximates F with a Taylor series expansion of F up to fifth order at the point variable equals 0. If you do not specify var, then Taylor uses the default variable determined by simvar, that is f comma 1. Okay, then for the second one, Taylor f var a approximates f with a Taylor series expansion of f at the point var equals a. So in this case, class, uh, I'm using the second one. Okay, so let us check class if we can, of course, use the first syntax and then check if we have the same answer. Okay, so let's have this example class. Find the Maclaurin series for sine x. Okay, so of course, class, manually, what you will do is to find the derivatives, some derivatives of your function. Of course, you start with the function sine x, then get the first derivative, second, third, fourth, then you may stop, right, class? Or you can continue. And then, what's next, class? You know to evaluate the function value by assigning x equals 0, right, class? Okay, then you collect terms, class, on that function values that will be the coefficient of your polynomial or series. Okay, so take note of the formula, class, of Maclaurin series, as well as, of course, Taylor series. So you present first your manual solution, then it's your option to present your MATLAB solution, class. Okay, so we go now, class, to this Maclaurin series for sine x. So I will clear the command window CLC, then I will declare the variable x, so since x. Then you now have Taylor, or rather, let's have first the function f equals sine x. Okay, so if this is cosine, class, you write cos x. If this is tangent, you write tan. By the way, class, MATLAB will also help you to identify, class, those trigonometric functions, no? Okay, so let's have that. So you just type your class what you're looking for. Let's say the syntax for tangent function. Okay, so I'm sorry, class, that should be tangent. Close that, tangent function. So this is the syntax for tangent. Hmm? Class. So maybe I'll just type trigonometric function, trigonometric functions. Okay, so let us check the syntax class. Okay, for function, sign of the out of the input sine, cosine of the input cos. Okay, so these are mathematical expression. This is the Matlab equivalent. Okay, class. So atan for arctangent or inverse tangent. Sin for inverse sine. So okay. So let's go back to our problem class. So we will now use Taylor, right class? So Taylor, here class we have capital T, right, equals Taylor. So you can directly use Taylor class. Taylor F, comma, variable X. Then we start with, what's the lower limit class? The lower limit is, sorry, there's no lower limit here. So the syntax class is L, I mean Taylor, open close parenthesis, F and X only. Okay. And then I think we need to write zero class also because this is Maclaurin, right? And then type pretty class. I have typed pretty a while ago class, right? Pretty uh ans. Pretty answer because this is the output class now provided when we have Taylor. The name of the function is ans, or the name of the output is ans. So that's the answer class. If I will not use zero, I will remove zero class. Do we have the same answer? Then pretty answer. Yes, because it evaluates class also at x equals 0. Okay, so that's the answer K class. Now I hope that you can see it. And then by the way class, if you want to have a specific order, okay, so let's say class, I'll just recall what I have typed class now. This one. Okay, so I want to have fifth order class. That's the answer. Y class. Because class manually, when we compute derivatives, we start with f class, right? F equals sine x. So that's your first order. Then first derivative will be now second order. Okay. Then second derivative is third order. Fourth derivative is fifth order. Third derivative is fourth order. Fourth derivative is fifth order. Okay, class? And this is the answer that can be obtained from this order 5. Okay, so suppose we have order 3. So the answer is just x. Okay, why? Maybe because there's a zero term class, right? Okay, so when you remove that zero term, so this will be short term class. Okay? The output will be in this manner now. Will be displayed in this manner. Okay, class? Questions? Do you have any questions, class?
Wala na po.
Okay. So, what about this class? Find the Maclaurin series for e to the x. Okay, so I will again clear the command class. So manually, you get the derivative of your function e to the x. So it's up to you class, up to what derivative then you evaluate using the function value at x equals 0. Okay, then you collect those coefficients and then use the formula of Maclaurin series to get the expanded form, okay, of the Maclaurin series for e to the x. For Matlab, so what you will do is to again type your, you need to declare your variable. So using syntax and then plus the function given here is e to the x. So the function here should be exp. Exp stands for e. Okay. Again, class, you may refer to the help center for exponential, for the syntax of exponential. So we consider expx. But then since this is raised to x, so caret x. Okay, so you may use pretty class if you want to check. Sorry for that. It should be pretty answer or PTF. Not pretty answer, pretty F. Okay, so that is e to the x, no? Also. So with that, we now use Taylor. Okay. Then we can again class take pretty ANS. So this is what is it gives you class. So as you can see right here. Okay, we follow class. So this is another example class that is find the first five terms of the Maclaurin series of 5 sine x. Okay, so this is the answer manually class, right? Okay, if we're going to include 0, the answer should be 1, 2, 3, 4, 5. It should be only up to this class, right? But then class, this is 0. So it should only be at negative 5 over 3 factorial x cubed. Okay? And maybe there's a typo error here, class. Okay, anyway, so we can use class Matlab to check. Okay? So what you will need to do is to type your function. Okay, so let's recall. We have already sin x a while ago class, right? So we have that. This one. But then we need to have 5, right? 5 asterisk sin x. Okay. So the declared variable is x class now. I've used since a while ago. This one. So you declare it once only if you will not clear the command. Okay, but if you will clear the command, you need to type your since x. Okay, you need to declare your variable using since. And with that, let's now have Taylor. And then we're going to find out 5 terms. Okay, so 5 terms class. So if I'm going to write pretty answer, oh, this should only be the answer class. So it does not include this one. Okay, class? Okay. So my MATLAB solution class, I did not write the order, no? So anyway, if we will not write this, it will give you the same answer. But then this is find the first five terms, okay? Well, including the 0, 1, 2, 3, 4, 5. So it will display 5x minus 5 over 3 factorial is 6, right class? So MATLAB already just give you the answer 6 times x cubed. Okay, next item class. Okay, what about this one? Taylor series. So this time for Taylor series, so what you will do is um, you're going to, so if still class the variable to is x, then you type now your function f equals, okay, so in here class, you have ln, right? Ln of x plus 3. So but we don't have ln in MATLAB. So what we have class is log. So we use that log x plus 2. Okay, and then class, what's next? So find the sixth term. So you now have 6. And then you now have 2 type pretty answer. So that's the answer class. Okay. There's something wrong with no class because this is x plus 3 while this one is x minus 2. Right class? And what I have here is log of 1 plus x. Sorry for that. There's uh, there's some error. I mean typo error, yeah. Okay? Do you follow class? Okay, what about this one? Find the Taylor series of the cubic function. By the way, class, I know already, class, why I have this different answer because let us go back to that. This is considered as Maclaurin because it is evaluated at x equals 0, right? So what we will do here is to use the value negative 3. So let's have that syntax again, class. So we need to include negative 3. So going back here, class, we should have negative 3. Enter a value for name. Name is x. Okay, so let's remove one of the order. Or we can use that class. Oh, increasing error siya. Okay, class. So I'll check what is the error here. Okay, so in this case, class, I have an error because I used negative 3. I assume that this came from here, but it's not. So there's a missing given in the problem. So it should be evaluated at x equals 2. Okay, so I replace x equals 2 here. Okay, and same syntax class. Of course, I just input 2 because this is now Taylor series. If you're not going to input 2 here, class, this is Maclaurin series. Okay, that's why what we have here, what we have obtained here, class, is incorrect for this problem, no? Because this is Maclaurin because of the default value, which is 0. Now, if you have input class the correct value to be evaluated for this function at 2, this is what you will obtain. So the same answer now, class. Okay? Questions? None?
None po.
Okay. So let's have another example here. Find the Taylor series of the function, cubic function x cubed. Okay, let's have this as our last example, class. Okay, so let me just clear this now, class. And then let's declare again sims x and then your function to be x cubed. Okay, then let's now evaluate class. Let's have pretty first to check if it resembles with a given function. Yes, that's correct. Then we now use the syntax. So replace this now by 3. Okay, and then we now have to type pretty. Oh, sorry, class. To be pretty answer. And then that is the result, class. So same as what we have here. Okay. So I have here 2 more examples that you can check. Okay. So that's all for our lesson, class. So if you notice, we only have limited commands, no? Okay. But then there are many topics that we have discussed in module 1. Actually, class, you can still check on the help center by typing the topics that we have discussed. Let's say you want to check if there is syntax for radius and interval of convergence. So just go here, class, to the help center. Okay? So just click this class, this magnifying glass, and radius and interval of convergence. Okay, so let us wait for a while. So this one, class. So there is a series convergence calculator, but then, class, you need to download. Okay, you follow. Hmm. So, but then, class, let me just emphasize to you that you need to show your solution. This Matlab tool or software will just be your help, no? To check if your answer is correct. Do you follow? Okay. So in your exam, if you it's optional to include your Matlab solution. You want to include it, it's okay, class. But then I need your complete solution manual, specifically manual solution. Okay? You follow, class. But then, class, that is for documentation uh, purposes, no? But then if you have any concerns, let's say on a certain problem, you can raise your question directly to me, direct message to me, Knap, and then I can address your problem. Let's say class Wiley did not accept your answer, so I can check your answer, then I can give you credit points. Because MATLAB will just give you a score. Let's say that is 5 points. So It will not give you effort points, right? So it will give you the uh, points if it is correct, but if it is not correct, you get zero, right, class? So that's why I want you to provide me a complete solution so that if you have concerns or issues, I can check your solution if I can consider it, class, for you to have a credit points. Okay? Do you follow?